Hello again. We're looking at 13e now, the shortest distance from a point to a line, using vectors. Okay, so here we are looking at example 10. We've got this line, xy equals 1, 2 plus t, 3, negative 1. Okay, so this is a moving object. So again, this would be the initial position after time 0, and this is the speed of the object. After every unit of time, it moves 3 units to the right and 1 down. Okay, so this is what that movement looks like from here over to here in the first time period, then to here, second time period, here to third time period. Okay, so I'll put that there for now. We want to find to the point P, we have this point P over here, point P, 5, negative 1. And the question says, what is the shortest distance from P to the line? So the shortest distance from that point to the line is going to be the one that goes straight up to be perpendicular to that line. Okay, perpendicular. You can notice if I choose any other angle besides perpendicular, I'll just choose a really wide angle just to demonstrate what I mean. If I choose a really wide angle over there, this red line is definitely going to be a lot longer than that black line going straight up perpendicular. Okay, so the key here is we know that it's going to create a perpendicular. We actually call this spot where that point comes up and meets the line, we call that the foot of the perpendicular. The foot of the perpendicular. Okay, we're going to call that point N. Point N. Okay, so to find the shortest distance, first thing we need to do is recognize that that shortest distance will be a perpendicular. Second of all, we need to be able to know how could we represent this point N? How could we represent the ordered pair of that point N? That point N could be represented using the parametric equations. The x coordinate could be represented by this. So 1 plus 3t. And the y coordinate could be represented by the y component right here. So 2 subtract t. Okay, so that's the ordered pair of our point N. Once we know what t is equal to at that point in time on the line, once we know the time, we'll be able to know what the exact ordered pair is and then be able to find the length of that perpendicular line. Okay, so we know perpendicular lines, when we dot product them, they equal 0. Well, here we have, we're going to consider this a vector. We're going to take Pn as a vector, and we're going to dot that with the direction vector from the line. And we know because they're perpendicular, that will equal 0. Okay, so Pn is from N back to P. So the x would be 1 plus 3t, and then subtract the 5 for the p. The y would be 2 minus t, and then subtract the negative 1. That's what Pn will be equal to. Dot that with the direction vector. We already know the direction vector. It's 3, negative 1. And we know that has to equal 0. So let's simplify this a little bit. We've got 3t minus 4 and negative t, 2 plus 1 plus 3. We're dotting that with 3, negative 1. Okay, so when we do that, we have 3t minus 4 multiplied by 3 plus negative t plus 3 multiplied by negative 1. That has to equal 0. Here, this will be multiplied by both, so 9t minus 12. Again, multiplied by both here, so plus t minus 3. We have 10t, negative, subtract 15 is 0. 10t equals 15, so t equals 15 over 10, or t equals 3 over 2. Okay, so now we know t is 3 over 2. We can take that back into our Pn. We know that Pn is represented by this vector. Okay, so we can pull that out. And t is 3 over 2. So 3 over 2 minus 4 minus 3 over 2 plus 3. This will be the vector Pn, which is this distance right here, from here to here. We're going to find out how long that is. Four is 8 over 2. Negative 3 over 2 plus 6 over 2. Okay. I'm going to bring that way over here. Sorry about the messiness. Here we go. That's 1/2. And 3 over 2. That's the vector Pn. We now have to find how long that is. 1/2 squared plus 3/2 squared, all square rooted. Equals root of 10 over 4 or root 10 over 2. And that is the distance. Root 10 over 2 is the distance, the shortest distance from P to the line. So the steps we did are, first of all, I drew it out for you so you could see when we're looking at finding the shortest distance from a point to a line, that's going to be the perpendicular. We can represent. Okay, so first step is representing that point N, the foot of the perpendicular, using the parameters from the vector equation, the x parameter, y parameter. Okay, then we know that if we take Pn, we can find Pn here using that ordered pair and this ordered pair. Take Pn, dot it with the direction vector from the line, that equals 0. Do that, solve for t. We get 3 over 2. Then we can take that 3 over 2, put it back into our Pn. This is Pn. We're finding out how long Pn is. Okay, and we found out how long that is. It is root 10 over 2. There we have it. Have fun.